one of the fundamental limitations of RLHF is that you don't actually know if the model has learned the thing you want to teach it, right? You have no guarantees that the model has learned what you have taught it. Some of the most successful companies right now are all in charge of like basically collecting data. And I guess they're not like covered as much in the news, but I feel like that seems like a huge amount of people. If you have this AI feedback and it can give you answers for everything, right? You would hope that the coverage is actually a lot more than the coverage you could get from human feedback.
Hi, I'm Craig Smith, and this is Eye on AI. Large language models are notoriously inaccurate, stringing together coherent sentences that often have little grounding in reality. To fix this, companies like OpenAI deploy armies of humans to try and nudge LLMs toward more accurate responses using reinforcement learning, a process called reinforcement learning with human feedback, or RLHF. This is obviously an inefficient and labor intensive way to tune the world's most powerful AI models, and researchers are looking for ways to automate the task. In this episode, MIT PhD student Yilun talks about new techniques for improving large language models through reinforcement learning with AI feedback, or RLAIF. Yilun explains how RLAIF circumvents the need for expensive and inconsistent human ratings by having AI agents debate and critique each other's responses. He shares insights from his research using multi-agent debate to enhance reasoning and accuracy, and we discuss the challenges of accessing proprietary models. I hope you find the conversation as interesting as I did. Hi, this episode is sponsored by Celonis, the global leader in process mining. AI has landed, and enterprises are adapting, giving customers slick experiences and the technology to deliver. The road feels long, but you're closer than you think. You see, your business processes run through many systems, creating data at every step. Celonis reconstructs this data to generate process intelligence, a common business language. With process intelligence, AI knows how your business flows across every department, every system, and every process. With AI solutions powered by Celonis, enterprises get faster, more accurate insights, a new level of automation, and a step change in productivity, performance, and customer satisfaction. Process intelligence is the missing piece in the AI-enabled tech stack. Search Celonis, Celonis, to find out more. This episode is sponsored by Crusoe Cloud. High performance cloud computing or low environmental impact, Crusoe Cloud was built because the innovations of the future need both. Crusoe Cloud is a scalable, clean, high performance cloud optimized for AI and HPC workloads and powered by wasted, stranded, or clean energy. Crusoe offers virtualized compute and storage solutions for a range of applications, including generative AI, computational biology, and rendering. Visit crusoecloud.com, that's CRUSOECLOUD.com, to see what climate-aligned computing can do for your business.
I'm currently a PhD student at the Computer Science and AI Laboratory. So I've been working on generative models for the last 5 years, especially on their application to like construct intelligent physical agents or robots. So I guess another name for generative models recently has been generative AI. So I've been working in this space for the last 5 years. And yeah, mostly I've been working a lot on diffusion models for quite a few years. And then recently also a reasonable amount on language models.
Yeah, so I'm interested in RLAIF, reinforcement learning with AI feedback. And I guess my first question, the reason I'm interested is because that's how OpenAI and the other large language model providers are trying to nudge their models into good behavior to stop hallucinating and things like that, which to me seems like a very uh, unsophisticated method to use armies of workers around the world, sort of scoring responses. So in RLAIF is a natural extension or solution. Uh, but am I wrong that reinforcement learning with human feedback really began as a strategy in robotics?
So not quite. Actually, in 2018, I was working at OpenAI. So
Hmm.
that's when they just started actually this RLHF. So there was a paper between OpenAI and DeepMind. I think this was in 2018. That was
Right.
which was I guess RL itself is a field that has been going on for like many decades. Deep reinforcement learning is also a thing that actually has been going on for even like for like 2 decades. Actually, even before DeepMind's DQN, there were quite a few works on deep reinforcement learning. Uh, but anyways, this RLHF idea at the time in 2018 was that RL agents had these would often exploit your environment, and they would like exploit parts of the environment that you really would not want it to. So essentially, like maybe you wanted to complete this race course, but it finds that it gets a lot of points by looping around the ship. So instead of completing the race course, it will end up looping around the ship an infinite number of times. So initially, the goal was that by having humans give feedback to RO agents when playing these interactive games, you could prevent the agents from prevent the agents from like doing very odd behaviors. And
Right.
then this involved, I think, around 2018 was when the first GPT model came out. So then there's the safety team at OpenAI, and I remember there were several people who were interested in the idea that you could use this idea of RL supervision to train the language models to like summarize or like to have humor, because it seemed like these are things that are very hard to teach the language model if you just gave it a bunch of internet text. So I
Right.
guess that might have been the start of this idea. And then afterwards, there were like a variety of papers, and then eventually, I guess I guess ChatGPT was a version of this like RL from human feedback.
Right. And just for those listeners who don't understand how it works, can you describe the RLHF, how it works in the sort of process? And when you were working on it in OpenAI, that was before the GPT models, or was that on early iterations of the GPT models? Or what were you using RLHF for?
So I personally was not using ROHF. At the time when I was at OpenAI, it was a very small company, I think around 40 people.
Right.
And then maybe, so I knew about all the research that was going on at the time. Uh, so this was right when the first GPT-1 model came out, or before that. So this was very early on. The focus of the company at the time was RL, and then there was focus on like this game called Dota uh, that was going on. And the idea of RLHF is that your model will generate different outputs, and then you'll have people rate them. Like people will say, "This is very desirable. This is not desirable," and then this gives the model supervision on like if you should generate this output more often or less often.
Hmm. And as I said, since these language models have blown up and hallucination has is such an obvious problem, there people have been using RLHF, and it's actually to guide the models into better behavior. Two things about that fascinate me. One is that you're only kind of nudging the model. Uh,
Mhm.
and is there some metric for how many times you need to push the model to stop it from doing something you're pushing it away from? But also, as this has as LLMs have exploded, there's like this new industry of human reviewers around the world. And do you have any sense of how many people are involved in RLHF for large language models at this point? I mean, the human reviewers.
Yeah. So I guess going on the first question. So yeah, I think that's one of the fundamental limitations of RLHF is that you don't actually know if the model has learn the thing you want to teach it, right? You have no guarantees that the model has learned what you have taught it. And then there's a variety of papers that have shown that you can take any of these large language models and like just add by adding some additional prompts, it's very easy to make them elicit behavior that you would have hoped that you had made the models forget. So yeah, a big issue with RLHF is that the reward function just like nudges the model towards doing something you want it to do. It doesn't necessarily doesn't necessarily guarantee that your model has learned this. I mean, on the other hand, though, you could say that human learning also like you as a teacher, you kind of nudge a student you with like this is the response you want, this is not the response you want, but you don't never necessarily know if the person has actually learned the thing you wanted to learn. Maybe they just have like copied the equations you've given it. Uh, but yeah, so along the first question, I think that is an issue with RLHF. Along the second question, how many people are rating these models? That is actually one something I don't really know very well. My my understanding is it's a lot. So I think based off what I've heard, some of the most successful companies right now are all in charge of like basically collecting data. Uh, and I guess they're not like covered as much in the news, but I feel like that seems like a huge amount of people. And I think the
Yeah,
job is very, I guess you could say boring because, and maybe scarring also because you see all this stuff on the internet and then your goal is just to label things.
yeah, and the yeah, I guess that's right. I mean, I hadn't thought of it in that regard. It is just labeling, right? It's like supervised learning labeling.
Hmm.
It's just for a different purpose. And and when you said some of the most uh, successful companies, you're talking about data prep companies, or
Yeah, like data, data companies that are focused on gathering data.
yeah, yeah. So this bringing AI into the picture seems like a natural solution. And can you talk about how you do that? How do you get an AI to rate uh, a response from a model?
Yeah, so instead of so like when you do RLHF, what happens is your model will generate different outputs, and then
Mhm.
people will just say this is good, this is not good. So in a very similar vein, you can imagine that you have two language models. One language model generates the answer, and then you give the other language model maybe the ground truth answer and the question. And now it can like basically assess how good the generated answer is. Like first, does it match the ground truth answer? And then it can like check the reasoning, like does the reasoning make sense to the language model. So that's a very simplistic version you can imagine of ROA for an AI feedback. And then there's like a variety of different ways to make it much more sophisticated. One way that I've been working on a lot is this idea of using multi-agent debate. So what happens is now, let's say I give you a question. What happens is you have multiple instances of your language model generate different possible answers to the question. So it's kind of like when you're trying to solve a math problem or you're trying to answer a question, you have like different thoughts in your mind. And like each of these voices in your mind kind of like talk to each other. So each of these language models like talk to each other, like try to like, is this answer consistent with my first thought? Is it consistent with my second thought? And then you can imagine that you have these like language models debate with each other. And then the answer you get at the end of this debate should be a more accurate answer than the original answer you have. So you can imagine that now this gets you better data, right? And then you can again use this data to like retrain your model. Yeah, the core idea is basically you can use the model to like get better data. Like you generate from your model, and then you can impose some structure on this generation process to encourage the model to like do a bit more like reasoning or like causal like chain of events or stuff like this. And then after at the end, the answer you get is an improved version of what the model would originally generate. So it gives you some improvement operation.
Yeah. And is there, so in the first, the more simplistic scenario where you're giving a model the ground truth
Mm-hmm.
in the prompt, is that you do that in the prompt, or you're connecting a vector database with verifiable or ground truth data?
Yeah,
How do you?
yeah, I think probably the simplest way is to just give it as a prompt. So you can ask the first language model, here's a question, generate an answer. And then the second language model, you give the original question again, and then you give the generated answer, and then you say, here's the ground truth answer. And then you can instruct the language model reflect and like describe what is correct versus not correct about the answers.
So walk me through that. Let's say you ask a model, what's 2 plus 2, and the model answers 5. And
Mhm.
then you have another model that,
Yeah, so let's say the first model generates 2 plus 2 is equal to 5. So what you do now is you give the second model, you say, here's so you give it the same question, what is 2 plus 2, and then you give it ground truth answer 4, and then you give it answer generated by agent 2 plus 2 equals 5, and then you can say can you check if this answer is correct and provide like feedback on like uh, what portions were correct or what portions were incorrect, right? So one thing you could do is you could like feed the intermediate generations of the language model, because the language model generates the answer step by step, right? And you can
Mhm.
like give it the first sentence and say, is this consistent with the right answer? You can give it the second sentence, say, is that consistent? And you can get like much richer annotations than just this is correct, this is not correct, which is in principle something you could also do with people, but it's very tedious for people to do this. So in practice, most of the time, the RLHF feedback that you get is just like holistic over the entire output.
Yeah. So, in these LLMs talking to each other, you don't have a human operator that's asking one LLM and then takes that answer and asks another LLM. This is all happening within the software between the two LLMs. Is that right, or is there some human oversight required?
Yeah, so in this debate procedure that I was talking about earlier, uh, yeah, there is no human oversight. And it's well, I think one big thing about ROAI, RL for an AI feedback, is this idea that you do not want humans to be your bottleneck,
Right.
because like LLMs, right, or like all of these models, they can be accelerated very quickly on hardware accelerators. But people like operate at a specific speed. They're expensive. Maybe they're inaccurate, right? So yeah, the goal would be that completely automate this as much as possible.
Right. But where does the LLM, the reviewing LLM, get the ground truth data from a vector database, or uh, yeah,
Well, I think there are two ideas, right? So one idea is that you could give that like the ground truth LLM the correct answer, right? Like if there are a set of problems that you want to teach the LLM to be more accurate on, right? You could just generate a bunch of questions, get a bunch of answers, right? Also, and then like use this LLM to like critique your answers. I think the thing that a lot of people want is assume that you do not have the ground truth answer. So even if you do not have the ground truth answers, right? Like let's say I want to like write a proof for like a mathematical theorem. I don't know the ground truth answer, uh, but I can like check to see if someone else's answer is incorrect. So I can like carefully look at the first step and say, well, this step is logical or this step is not logical. I can check the second step. So one thought about this like RL for an AI feedback is in the same way to like how people you can like prove mathematical proofs by sequentially like just checking and making sure everything is correct to your knowledge. You can imagine each of these LLMs like check each other and see is every single step the way correct, and if every single step is rational and you get the answer you want at the end, right? And again, even if you don't know what the ground truth answer is, right? We still know this is a satisfactory answer or this is not a satisfactory answer, right? So like just by like it's you can imagine it's a way to like search through the space of possible solutions. So having one
Right.
LLM like generate many different things and having the other one like kind of like prune the ones that are probably wrong. And if you prune all the bad ones, then you get the right answer. And
Yeah.
if you have a model that can always generate the right answer, right? It's a more intelligent model than the one that's not that's just generating all possible answers.
And this, I mean, I understand how that could work for a logical proof or a mathematical equation, but how does that apply to a more general uh, and less precise questions and answers? I mean, if I ask an LLM, what's the history of this town? And and it comes back with a hallucination that's not correct. How does the other LLM know to check that first LLM's answer?
Yeah, so I think this is where so I guess I talked about a bit about how like in some of my work on RLAIF, RL for an AI feedback, I use this idea of having multiple models. So I think if you only have a single answer, right? So like if I ask you like when was this person born, and then the LLM just makes up some number, there's no way to verify if it's correct or not. But the thing about LLMs is they can generate multiple answers for a question, right? Uh, so if I ask the LLM when was this person A born, and then it gives me like 1876, and then it tells me it's 1896, and then it tells me it's like 1895. Now you have multiple different answers, right? And now your critic can say, well, clearly something's amiss here because none of these answers are consistent with each other, right? So I think when you introduce this idea of not just having one model generate, but like have multiple instances of the model generate different solutions, then you can kind of you can kind of like verify issues with the like causality or like the way the chain of reasoning of language models, right? Like you can identify things that are like logically inconsistent by just having multiple generations come out.
Yeah, so by having multiple generations of or multiple agents debating, as you said at the beginning, is that what you mean?
Yeah, that's what I was thinking.
And I mean, uh, this is all happening in some vector space, right? It's not happening in actual uh, language on a screen, and that's then being fed to the other agent. How mechanically how does it work?
Yeah, so actually, so for the work that I've been working on debate, you actually have the language models generate language outputs explicitly, and then each of the language models takes in these language outputs from other models, and then it gives feedback on that. So it's purely in the language space. And like
Hmm.
probably it could be more efficient to be able to do it in some type of vector space. Uh, but actually, there's some like desirable properties having it in language, right? If you can have all these agents reasoning language, then we can kind of understand what the agents are doing, also, right? Like it's a hard constraint that forces the model to like be kind of reasonable in a sense, right? Because if you do it in some abstract space, maybe you as a person, we have no idea what the model is doing, and it might also be finding all types of like like cheating ways to like communicate. So like having all of this self improvement be directly in language, I think is a desirable thing also.
And so in your research, are you getting uh, printouts of these conversations between AI agents? How do you monitor what the conversation or the debate is
Yeah,
between
yeah,
agents?
yeah. You can actually, so you can actually see the entire printout of the conversation. So like it starts with like, You give it a question, and then model, and then agent A will say, uh, based off the order of operations, I think it's X, Y, Z, and then here's the final answer. And then agent two will say, based off this other thing, I think the answer is A, W, A, B, C. And then each of these agents will respond to each other. So like one agent will say, well, actually, I think the second agent is wrong. I think it should be this. And the second agent will be like, oh no, I am correct. And then like you can have this like multiple rounds of like conversation. And then like essentially at the end of this conversation, each agent will be like, based off the what I've seen of the other agents, I think the answer is like ABC. And then you just take this final answer.
And it will converge eventually to one answer, or do you end up with LLMs that will never agree?
Yeah. So most of the time, you end up converging to the same answer, or like converging to one answer. I think this might be due to the fact that the models. So the models are trained with these models have been trained to converse with people, right? And they've been trained to converse with people in such a way that they are not very stubborn. Like if a person constantly suggests an answer, they will respond to it. So what we notice is when you try to repurpose this mechanism to have multiple models talk to each other, right? Then the models are very diffident to other models. So it's almost all the time they will converge to one answer.
Hmm. And then you check that answer against ground truth or against sort of
Yeah. Basically, we just check against ground truth and we see how good it is.
yeah. And so what are presumably you have metrics of how uh, different strategies have improved uh, response accuracy or something like that. But how do you measure that?
Yeah. Mm, so there are like a set of existing benchmarks, and then what you can do is, and roughly they're in the style of, here are a set of like math problems, and I know the ground truth answer. So basically, you take the final generation from all the agents, and then just compare the accuracy in which that final answer matches the real answer. Is one thing you can do. In a similar sense, for like factually correct things, you can ask the model to generate all these facts, right? And then you can get ground truth facts about the subject of interest, and then you can basically check the accuracy in which the language model generated things matches the ground truths. Uh, so always there is so all of these problems there is like for to evaluate this approach. There's always like you can always come up with a database of answers and like check those. I mean, the hope would be that you would always have these benchmarks that you know the answers for, so you can like concretely monitor the progress. But then ideally, you'd want to do it on all types of subjects where you don't have very clear ways to monitor how good it is. Also,
Mhm. Yeah, because and again, is this in the fine tuning stage that you're doing this, where you're trying to improve the accuracy of uh, one model by having it debate with these other models, or is this an architecture for uh, as a consumer? You know, I interface with a language model on my screen, but in fact, in the background, there's this debate going on between multiple models that then converge on an answer before supplying me with the answer. I mean, is this a training strategy, or is this actually a new way of building large language models?
yeah, I mean, so in the paper we wrote about this, we primarily focused on this application where you finish training this model, and then this is a way to get better answers from the language model. But I mean, I think one thing that I've been very excited about is this idea that this is also an improvement operator, right? During training time, also, this is a way to get like RL from AI feedback, and like I've been recently talking to several companies that have also been, or like I guess I've been training the large language models, and they're also like thinking, like exploring one of these strategies. Uh, so yeah, so I mean, it's. I think it could be either, right? In general, I think anything that you can do for AI, like any technique for AI for an, like RL from AI feedback. Each of these strategies gives you some mechanism for how good an answer is, right? So you can always
Yeah.
use that as a test time thing, also as well as a training thing. I think they're like two flips of the same coin. Like I don't think one is very different than the other.
Yeah, but if you're using this strategy to train the model,
Mm-hmm.
uh, that's one cost. But
Uh-huh.
if you're building it into the model so that the model is going through this process to produce every inference,
Mm-hmm.
it seems to me that would be extremely costly. So actually, on one side, if it's built into the inference, every time you ask a question before you get the output, there's this debate going on in the background. That would increase the cost, right? Uh,
Yeah.
but
Yeah.
but then on the other hand, if you're using it for training, and this is something about RLHF also, or uh, trying to nudge these models, you do it, for example, on you know questions where there's a very clear ground truth answer, but that doesn't mean the model will necessarily generalize to all questions, right?
At training time. Well, yeah. So I think yeah. So definitely, it's the case if you use it at test time, the computational cost is much more. Uh, I feel like it always seems like a thing though that if you have a thing that improves performance, the actual computational cost is always like not the thing to care about the most because that cost always decreases year on year. So I feel like
Yeah,
it's always been the case that like every year on year things get much cheaper and cheaper to do. So like if you have something that can fundamentally improve the performance of your system, it seems like worrying about cost is not the most important thing because people always find ways to make things faster. Uh,
yeah,
but yeah, on the latter point though, yeah. So if you well, ideally, like any type of like RL from AI feedback, you would be able to apply it on arbitrary prompts, hopefully, right? Because like ideally, you construct this interface, right? That like all the models can just autonomously like talk to each other and like generate answers. And as long as the models can autonomously like generate answers, you can give it all types of prompts, right? Like one issue with having people rate like the accuracy of something is it's really hard to rate the accuracy of like not so well known people because like you would have to like search for ages on Google and maybe to verify one passage that's generated, maybe you need to spend like 2 hours. Uh, so it's not very scalable, right? But and then like for lots of prompts, maybe there's just no easy way to do it. But then if you have this AI feedback and it can give you answers for everything, right? You would hope that the coverage is actually a lot more than the coverage you could get from human feedback.
right. In the training phase, you mean?
Yes, in the training phase.
In the training phase, because that's an issue, uh, right? When I mean, the hope in RLHF is that the model will eventually it'll learn improve behavior. It'll learn to reason more carefully, or to learn to double check itself or something in the background, so that it then can generalize that behavior to any question that it's asked. But that's not necessarily the case. Is that right?
Yeah, that I mean, yeah, I guess with all these things, you can never know, like you can never guarantee like this model will like see every possible thing, right? These models have like billions or trillions of parameters. Uh so it's hard to guarantee, but the hope would be that you get more and more coverage. Like the more scalable your automated critique is, the more possible prompts you could cover. And hopefully if you cover all possible prompts, maybe it will be very difficult to elicit odd behavior from the models.
Yeah. And on the improvement, on the measured improvement, the is there have you, I mean, how do you measure that? So against the benchmarks, like before RLAIF, you get a 60% score by I don't, and that's another question. How do you score? I guess on a benchmark, yeah. So you have a 60% accuracy, and then after RLAIF, you've moved it up to 80%. I mean, what are the numbers that you're working with in terms of the improvements that you're seeing with these strategies?
Yeah, so I think right now, yeah. So what you would see is like maybe on this benchmark, it used to be 60%. Now it goes to 80%. So yeah, you would want to see these like consistent improvements across a wide variety of benchmarks. I think there is a question where let's say the models get really good, right? Like which I think they're very very far away from at the moment. But if they were to get very very good, and maybe they like do perfectly at all these human benchmarks, right? Then how do you assess the performance of these models? And again, I think there's a nice idea from like this like multi-agent like debate kind of thing because you can use something like an MMR system. So like for all these like chess and like Go playing bots, right? They are much better than people, but we can still quantify how much better they are by pitting these agents against each other. So
Mhm.
like if the agent is like able to beat another agent 100% of the time, uh, then like it's probably a much more intelligent agent than the original one. So the hope would be that like if you use this like type of multi-agent competition is your improvement operator, you can also use the ease at which like the language model is able to generate solutions to convince another agent as a measure of how intelligent it is. So like if like as the model gets more and more intelligent, ideally it would be much better. Like it would maybe blow away the other model, right? Like you can like speak so eloquently or so correctly that like you just cannot like you will always outcompete the other one. And then like maybe that could be a metric for improvement at that point. But I think that's very speculative. I think the models right now are very very far away from being human level, and probably my guess is in the next like year or so, or at least upcoming several years, probably we will have plenty of benchmarks to see numbers go up a little. Uh,
Yeah, but in your research, how much have has the performance improved with these strategies? I mean, do you see a two
yeah, I see
percent
like
improvement or a yeah?
I see like a 20% improvement, which is a decent
Yeah,
amount. And I think
yeah.
so. We wrote this paper in May, and I think there's been several follow-ups on this paper. And I think some of the large companies, I think for example, Anthropic might also be exploring debate. Uh, but yeah, um, it seems like there's a boost. It doesn't seem like well, we don't have access to the large language model, so we actually cannot do this full on training at a large scale. So we don't see these like new capabilities or anything like that. That would be the hope if it could. But yeah, right now we see this like boost in like these raw numbers.
Yeah, and if you don't have access to these proprietary models, what language models are you using in your research?
Yeah, so we have API access to these models as everyone else does. So like this way we would propose to do this RLAI feedback. It doesn't require the weights of the network. We can directly it's more of a test time thing like we were talking about earlier where you can still use this to improve your performance at test time. But yeah, the big issue is we can't fine tune the model or like use that to improve the performance. Uh yeah, I think that's a bit of a unfortunate thing at the time. I think because there is a pretty large gap at the moment with all these open source models and the ones that are like being used commercially. So it feels like likely the pace of research would like or the pace of improvement could be improved a lot if the weights were made available to everyone. But the issue is that I think there's so much money and incentive, commercial interest on this side that that's unlikely to happen. But yeah,
Well,
uh, uh,
but what about using Llama 2, for example, where you
yeah, so
have the weights?
I think the issue with Llama 2 is still it's pretty poor actually at the moment. Um, so lots of people talk about how oh it's really good and stuff like this, but it still is like it like so some papers claim that like if you use llama 2 you do lots of fine tuning it can match gpt 3.5 performance. uh what we find is that like yeah it can match gpt 3.5 performance on one task, which is a task they spent like the last month optimizing for, and it's like far
Yeah.
worse on every other task. And then like even gpt 3.5 it's like much like for like this debate stuff and these much more a lot of these AI feedback stuff, like GPT-4 is much better at this than 3.5 is. So it feels like if you're stuck with things that like are like much worse than 3.5, it's very hard to get improvements. I mean, one thing that was kind of interesting is so after we released this paper, there was another group of people. They actually just tried it on these open source models, and they actually also noticed the improvement, but it was like 2% or 3% compared to like our 20%. So I think there's like a pretty big disparity between like these commercial models and the ones that are available at the moment.
Oh, that's fascinating. Yeah. And that's another topic that I'm really interested in is whether open source for generative AI is the future, or whether the open source community just can't marshal the resources, the financial resources necessary to compete with proprietary models. And Meta's the only one that's sort of stepped forward to commit serious resources behind an open source LLM, but they're going to have to keep that funding at a very high level in order to compete. And do you think that open source uh, generative AI will eventually, that Jan LeCun says that that's the future, that all these things will be open source, but and then I talk to other people who say no, because these the resources are concentrated in these very large companies, and open source will never be able to compete. Meta will not be able to keep up with Anthropic or OpenAI by improving the open source models. So what's your view on that?
Yeah, I feel okay. So I do think at the moment there's a pretty massive gap between the open source language models and the internal ones. Uh, I think a huge reason for this gap is actually because of data. So I think OpenAI has spent a lot of time like gathering very customized data to make the agent look very appealing to people. And I think this like lack of data, it feels like it's possible. I don't know. So I think one thing is that OpenAI and Anthropic, which I guess was from OpenAI actually, uh, they were doing this large language model scaling for like several like 4 or 5 years, and as they were also trying to like looking for how to like commercialize it like for the last 2.5 years also. And I think everyone else kind of just like suddenly realized they had to do this. Maybe a couple like I guess now at this point like almost like 9 months ago. But like around 9 months
Mhm.
ago, people were suddenly like, "Oh, we need to spend time getting these large language models." So I think there's a big time difference at the moment. Uh, and I think yes, the open source models are much worse. I think even the company models, I think Facebook's model internally, my guess is, I don't know, I don't know any information about this, is probably much worse than the OpenAI ones. And I think a lot of it is just a time thing. So I would hope that maybe in a year or two, I think, or maybe even in 1 year, maybe things will catch up. But yeah, at the current moment, things are uh, very different. I think one thing that people seem to constantly say is they feel like there's a lot of technical knowledge to train these models, and then that's one reason why OpenAI is so much better than the other ones. I actually don't think that's the case. I do believe that. I mean, there are. I think there are a couple of things that people don't appreciate about training the models. I think one big one is like like finding hyperparameters on smaller models and having the exact same hyperparameter skill for larger ones. But like besides the a few couple technical tricks, I think the main thing that is missing right now is just the data,
Mm.
and like yeah. So I think because it's just the data, I feel like maybe in a year or two people should catch up. I don't think
Yeah,
there's like technical know-how that's missing.
yeah, and the GPU constraints and the cost of the compute, that you don't think that's a barrier to open source.
Yeah, I think that could be a barrier. So yeah, it is true that the GPU cost is quite large, like probably like like maybe even 100 million, I guess. Like maybe hundreds of millions, maybe even a billion was like huge models. Uh, Yeah, I mean, I feel like maybe we need some type of like a research center or something like this, or like government funded things. So like I guess like with particle accelerators and particle physics, you have the Large Hadron Collider, and that's like hundreds of millions of dollars or more.
Yeah.
So if we had an equal size effort, I think you could totally do this. Uh, yeah, but actually, I do feel like at the moment we don't even have. I feel like there's a disconnect between what people are yeah, it does feel like there's a big disconnect between what people constantly say online right now in the open source community. Like everyone's like, oh, you just need a small model, you just need to fine tune it a little, and then it will reach their performance. In the actual performance, like, uh, yeah, I think we people maybe should focus a bit more on using more GPUs. Yeah, that could be a thing that could be problematic.
Yeah. And then you're also working in robotics. Is that right?
Hmm.
So how does this work relate to robotics?
Yeah, so I guess throughout my PhD, I've been very interested in the idea of artificial intelligence. Um, in particular, I think that like to have artificial intelligence, we really need to have it physically in the world. So we need an agent that can visually understand the world, that can like physically act in the world, have like intents in the world, and like interact with other agents. So I really believe in this like physical AI hypothesis. Uh, so yeah, and I see that robotics is basically the is like the instantiation of like having like a physically intelligent AI agent. So to me, I guess like this multi-agent debate stuff, it's one way to like try to get AI, to get a more intelligent AI. It can like I think this idea in general could be applied a lot in different ways. So right now, I guess it's just on language models, but you can imagine that you have like different models like in the robot processing system, right? So maybe you have a video generation model that generates possible actions you want to do, right? You have some type of action model that takes images and predicts actions that you want, right? And you can imagine each of these models talk with each other. Like the action model says, "You gave me this image. This image is not possible. Go, please refine it a little," right? So you can imagine that you have a network of these like individual modules that like all are talking with each other, and then like when you have like this a set of these decentralized models that like are all talking with each other, maybe that whole thing uh, can be like some like distributed operating system to like construct an intelligent robot. But like I feel like this idea of like debate or like the self improvement thing like could be like broadly applied across like multimodal models like on a robot also.
Yeah, yeah. It seems I've had Peter Abil, I'm sure you know, on the podcast, and Sergey Levine and different people working in robotics, and uh, it seems that the barrier in robotics is not so much uh, the brain AI, but it's just the mechanics, the miniaturization of motors and all of that stuff. Do you feel that, or is that is the hardware going to catch up uh, with the software, with the AI?
Yeah, I think so. I agree that hardware for robots is like a lot worse than what people have. Yeah, we don't have tactile sensing. The arms are very, very awkward to use. They are very constrained. But I think when you give a person a remote control of the robot, they can do a lot of tasks in the kitchen, right? Like almost every task you can imagine, you can actually do by remotely controlling the robot. So
Hmm.
yes, those are big issues. Uh, but it feels like we're also missing the fundamental intelligent portion also. Like I as a person can do a lot more than I can autonomously code my robot to do at the moment. And I think that if we could do more autonomously with the robots, then like people would be much more interested in robotics. Like I think then we would have like the interest in hardware to like get better hardware to train robots. I think the thing is like there's no proof of concept of AI working in robotics still. That makes it so that people aren't very interested in like trying to get better hardware for the robots.
Now that's interesting. Yeah. Okay. Well, we're almost up to an hour. I don't want to keep you over, but are there areas of this that you're working on that I haven't asked about? that listeners might be interested in?
Uh, oh, I mean, I think there's one kind of interesting idea that I feel like. So I feel like everyone, and it's kind of related to this thing I was talking about this like multi-agent debate is a way to improve these language models. I think right now, everyone is working on these like very giant monolithic model that can like do everything. It can like sense, it can perceive, and stuff like this. But I feel like our brain is actually very like decentralized, right? Like we have areas for motor control, we have areas for vision, we have areas for memory. So I think it's a cool to think about like this idea of having not a single AI, right, but like have a society of AIs in your mind. Like you have a bunch of different small agents that are talking to each other, and then like that's how you actually function. Like you have one thought process that's trying to remember things that you're doing, another one that kind of perceives what you're doing. So yeah, I think that's an interesting idea that I feel like maybe people would also find interesting to think about.
Yeah. And where did you do your undergraduate?
I actually did my undergraduate at MIT also.
Oh, okay. And where are you going to go after this? Are you going to stay in academia?
Yeah, I'm planning to stay in academia at the moment.
Yeah. And I'm curious why. I mean, these days you don't have to leave academia to go into industry. I mean, all these guys, Jan LeCun, NYUF, Meta, or Jeff Hinton. I mean, he's retired now, but Google and University of Toronto. I mean, there's a lot of opportunity to do both.
Yeah. So I think if you had asked me this like maybe 1 or 2 years ago, I would have been like a lot more less certain because it feels like at the time, yeah, it felt like you could do very open ended research both in industry as well as in academia. I feel like nowadays because there's so much commercial success with these models, uh, the research you can do in industry is actually very limited. So if you want to work on RL agents without any language model, you can't really do that. Like there's a huge push for you to work on RL for language models. Or like if you say, I don't believe that a single large language model will solve everything, which I don't know. I've been like playing around. So like during the summer, I was working at Google. Earlier, I was working at Facebook. Like I generally have been playing a lot with these like vision language models. They still seem very far away from like actual intelligence with the vision side. But like even if you like but if you don't believe in this hypothesis, you still have to work on this because that's the vogue theme, and people think that it's so promising commercially that like that's the idea to work on. So I feel like nowadays you have very little freedom in industry, and I think it's actually just been in the last year that this has happened.
Hi, this episode is sponsored by Celonis, the global leader in process mining. AI has landed, and enterprises are adapting, giving customers slick experiences and the technology to deliver. The road feels long, but you're closer than you think. You see, your business processes run through many systems, creating data at every step. Celonis reconstructs this data to generate process intelligence, a common business language. With process intelligence, AI knows how your business flows across every department, every system, and every process. With AI solutions powered by Celonis, enterprises get faster, more accurate insights, a new level of automation, and a step change in productivity, performance, and customer satisfaction. Process intelligence is the missing piece in the AI enabled tech stack. Search Celonis, Celonis, to find out more. This episode is sponsored by Crusoe Cloud. High performance cloud computing or low environmental impact, Crusoe Cloud was built because the innovations of the future need both. Crusoe Cloud is a scalable, clean, high performance cloud optimized for AI and HPC workloads and powered by wasted, stranded, or clean energy. Crusoe offers virtualized compute and storage solutions for a range of applications, including generative AI, computational biology, and rendering. Visit crusoecloud.com, that's CRUSOECLOUD.com, to see what climate aligned computing can do for your business. That's it for this episode. I want to thank Yilun for his time. If you'd like to read a transcript of today's conversation, you can find one as always on our website, Ion AI. That's EYE-ON.ai. And remember, the singularity may not be near, but AI is already changing our worlds, so pay attention.